This is our thermal energy presentation by Charlie Kramer and Chandler Zartman. Intro to thermal energy. Thermal energy is the internal energy of an object due to the kinetic energy of its atoms and/or molecules. The three types of thermal energy are convection, conduction, and radiation. The formula for thermal energy is Q equals mc delta T. Q is the thermal energy, M is the mass, C is the specific heat, delta T is temperature difference. Conduction is the transfer of thermal energy with no overall transfer of matter.
For this example, we heated up a knife and used it to slice the styrofoam surfboard. Conduction is shown here. As the knife slices through, it separates the two sides of the surfboard. Thermal energy, while it can split it apart, that thermal energy can be used to mend items also. As shown here with the surfboard being reconnected via the heat melting it back together. One of the reasons why a pendulum cannot keep constant motion is because of thermal energy. Heat would be lost through friction every single time the two marbles or items in the pendulum would connect with each other.
The second type of thermal energy is convection. Convection is the movement caused within a fluid by the tendency of hotter and therefore less dense material to rise, and colder, denser material to sink under the influence of gravity.
An example of this is boiling water in a pot. The water heats up at the bottom of the pot. It will slowly rise to the top, in which it will then cool and fall back down to the bottom, therefore starting a cycle that will continue until the heat is all used or it is at the equal temperature. A boiling pot of water, while it has convection, it also has conduction. The part in which the pot is touching the stove is conduction, and the part in which the metal is touching the water is also conduction. The only convection is among the water touching the water itself.
The third and final type of thermal energy is radiation. Thermal radiation is electromagnetic radiation generated by the thermal motion of particles in matter.
The largest known form of thermal radiation is the sun. Its rays come from all the way from the sun to the earth.
Another example of thermal radiation in day-to-day life is toasting bread. Nothing touches the bread in the toaster, but the filaments in the toaster produce heat, which radiates to the bread to make it toast.
Here we demonstrate radiation with a lighter and a balloon. The lighter and the balloon is a result of two types of thermal energy transfer: radiation, which caused it to heat up, and then convection, which is the air inside. As it was moving, it ended up causing it to expand and therefore explode. As the lighter gets closer to the balloon surface, the radiation becomes stronger because it has less distance to travel and therefore less is sent in other directions.
This is the end of our presentation over thermal energy. I hope you learned something new and enjoyed.